Hi, good evening everyone. It's my honor to give this video presentation to represent our project in the course of the network security system. So the title of our project is the TCP/IP attack. So I'm Oi Kok Ming, metric number 187862, and my member is Sun Jianyue, metric number 187919. The introduction. The TCP stands for the Transmission Control Protocol. It is a core protocol of the Internet protocol suite. The TCP attacks use the IP address which are not fixed with the MAC address when it is created. When the TCP/IP protocol is created, it did not consider much threat on the Internet. Thus, it lists a lot of ways to attack the TCP on the IP protocol. The TCP is in the transport layer. It provides the host-to-host communication service for the application, and it has a flaw which there is no security mechanism was established into the protocol to protect the protocol. So basically, this is the configuration of the three machines, which represent the victims, attacker, and the server. So the client represents the victim with the IP address 10.0.2.5, and the server represents the server with the IP address 10.0.2.6, and the attacker represents the attacker with the IP address 10.0.2.7, and those three are connected in the same gateway. The tools used in this project, it includes the network tool and the SCPI tool. The network tool basically sends out the network packets of different types and with different content. It runs the command like sudo networks number, and at the back is the parameters. For the SCPI tool, right, it is a powerful interactive packet manipulation program. It is better than the networks as the networks is not being maintained. Task 1. Slim floating attack. It is a type of distributed denial of service (DDoS) attack. It exploits the part of the normal TCP three-way handshake for the consumer resources on the targeted server and make it unresponsive. Below is a diagram of the TCP three-way handshake. And first thing first, the connection required by a client by sending a SYN synchronous message to the server. The server will be acknowledged and sending synchronous acknowledge message back to the client. Then the client will respond with an acknowledge SCK message and make the connection be established. So the step of conducting the TCP SYN floating attack. Firstly, the telnet connection between the server machine and the victim virtual machine is established by using the command telnet 10.0.2.5. Secondly, the VM login, SEED, and the password DEES are keyed in to establish the telnet connection between the server machine and also the victim virtual machine. At the attacker virtual machine, a command sudo networks 76-I 10.0.2.5-P23 is typed on the terminal, and the attack is launched on the connection between the server machine and the victim virtual machine. On the victim virtual machine, a command nested-an GIP23 is typed on the terminal to see the connection status on the virtual machine. Here is the result of the TCP SYN floating attack. As you can see in the diagram, we can check the half-open connection using the nested command. Certain number of the half-open connection marked by SYN receive. It means that victim will not be able to acknowledge and will not be accept new TCP connection anymore. It is how the TCP SYN floating attack works. Thanks for watching the video of the demonstration on the task 1, SYN synchronized floating attack. Now moving to the task 2, the TCP reset attack on the telnet and SSH connection. TCP reset attack is executed using the single packet of data which is spoof TCP segment crafted and sent by the attacker. It tricks two victims and to abandon the TCP connection and interrupt the vital communication between them. An attacker will send a fake message to the two victims and telling them to stop using the connection immediately. The network tool and SCPI tool will be used in this task to carry out the TCP reset attack for both telnet connection and also SSH connection. Below is the diagram of the TCP reset attack. This is a diagram to show that how the TCP reset attack works. An established telnet connection between the two users A and B, attacker can spoof an RST packet from A to B and break up the existing connection. If the attacker can construct the TCP reset packet correctly, it can be successfully in this attack. Step of conducting the TCP reset attack on the telnet connection using a network 2. A telnet connection between a server machine and victim virtual machine is established by using the command telnet 10.0.2.5 and attack command sudo networks 78-d emp0s3-f dst host 10.0.2.5 and port 23 is run on the attacker virtual machine to break the telnet connection between the server machine and the victim virtual machine. The telnet reset attack is launched on the terminal of attacker virtual machine. This is the result of the TCP reset attack on the telnet connection using the network 2. The connection to host lost between the server machine and victim virtual machine. Here is a diagram to prove it. And next is the diagram on the victim side. The connection showing the reset acknowledge and TCP acknowledge and sync segment between the victim and the server. Next is a step of conducting the TCP reset attacks on the telnet connections using the SCPI-2. A connection is established between the server machine and victim machine using the telnet connection. Source port, destination sequence number and the acknowledgement are checked on the victim virtual machine using the Wireshark for the configuration in the TCP reset attack code. A TCP reset attack is conducted by using the Python code. A TCP reset code is typed on the editor of the attacker virtual machine and saved in the desktop of the attacker virtual machine. Then the TCP reset attack is launched on the terminal of the attacker virtual machine. Here is the result of the TCP reset attack on the telnet connection using the SCPI-2. As you can see the diagram below, the connection showing reset between the victim and the server. It means the connection between the server and the victim is no longer exists. Next following is a step of conducting the TCP reset attack on the SSH connection using the network 2. An SSH connection is established between the server machine and the victim virtual machine by using the SSH command. The command to establish the SSH connection is SSH seed 10.0.2.5. An attack command sudo networks 78-d emp0s3-f dst host 10.0.2.5 and port 22 is run on the attacker virtual machine to break the connection between the server and the victim. The TCP reset attack is launched on the terminal of the attacker virtual machine. Next is the result of the TCP reset attack on the SSH connection using the networks 2. As you can see the diagram above, it shows that the connection showing the reset acknowledge and the TCP acknowledge and sync segment between the victim and the server. The picture below showing the SSH connection between the victim and the server, and it shows that the connection has been reset. Next, we will talking about the step of conducting the TCP reset attack on the SSH connection using the SCPI-2. As the procedure is same like on the telnet connection, an SSH connection between the server and victim is established by using the SSH command. The command is to establish the SSH connection is seed 10.0.2.5. Source port, destination port, sequence number, and acknowledgement on victim virtual machine are checked by using the Wireshark for the configuration TCP reset attack. A TCP reset attack is conducted by the Python code. A TCP reset Python code is typed in the editor of the attacker virtual machine and saved in the desktop of the attacker virtual machine. Then the TCP reset attack is launched on the terminal of the attacker virtual machine. The following is the diagram of the result of the TCP reset attack on the SSH connection using the SCPI-2. As you can see the diagram above is the connection showing the reset between the victim and the server. The diagram below showing the SSH connection between the victim and the server, and it shows that the connection is lost. Task 3. TCP reset attack on the video streaming application. This is a very interesting attack on the TCP reset attack. The video streaming application could be triggered by a TCP reset attack. The attacker aims to disrupt the TCP session which established between the victim and the video streaming machine and make the connection to be terminated. After the victim chooses a video, TCP session will be established between the victim and the virtual machine and the content server, so the victim could do the streaming on video. The step of conducting this TCP reset attack on the video streaming application using the network tool. The first step, Mozilla Firefox browser on the victim virtual machine is open and the YouTube website is served to stream a video. A terminal on the attacker virtual machine is open and a network command sudo networks 78-i 10.0.2.5 is typed, and to launch the attack on the virtual machine of victim. The victim will be suffering from the streaming video from YouTube website and the connection of the streaming will be terminated. Here is the result of the TCP reset attack on the video streaming application using the networks tool. As you can see the picture inside, the connection showing the victim and the YouTube website is terminated and showing the acknowledge and TCP acknowledge unseen segment. This proves that the connection between the victim and the YouTube website is terminated. Victim is suffering from the streaming and loading the content from YouTube website and the connection is terminated. As you can see the diagram below, the YouTube is loading and the content cannot be watched by the user or the victim. Now I will pass to Jian to explain the tasks following. Thank you.
Thank you, Gomeng, for the presentation. Now I will continue the presentation, which is a task for TCP session hijacking. First and foremost, I will explain the TCP session hijacking. TCP session hijacking is a process in which an attacker can interrupt the telnet established connection between the two machines by injecting a malicious content into this session. This means the attacker will spoof the package with the correct source IP address, source port, destination IP address, destination port, sequence number and acknowledgement, and send into one of the machines. So the machine will run the malicious command after receiving the packet from the attacker. So this means the machine is attacked by the TCP session hijacking attacking. So how we conduct the TCP session hijacking with a network tools? So first and foremost, the wire shard of the attacker virtual machine is open. Then a telnet connection between the victim machine and the server machine is established by using the telnet command, which is a telnet 10.0.2.5. Then the command nc is typed and run on the terminal of the attacker virtual machine to set up the TCP server listening on the port 9090, whereas the command cat is typed and run on the terminal of the server machines to reply a connection request to the attacker machines. So these two commands are used to let the attacker listening in on the port and receive the message put into this port. Then the details such as the sequence number, source port number, destination port number, source IP address, and the destination IP address of the target TCP connection are checked from the wire shard on the attacker machines after running the telnet command. After that, the command Python is typed and run on the terminal of the attacker machine. So after that, the command cat home seed secrets def TCP 10.0.2.7 9090 encode hex is shown in the slide. Is run on the terminal of the attacker machines. It's used to convert the data into the hexadecimal form. After that, the command is shown in the slide. Is typed and run on the terminal of the attacker machine to spoof the new TCP package and send into a victim machine. So how we conduct a TCP session hijacking with another tool, which is Scapy tools. So the first four steps is same with using a network tools. First, the wire shard on the attacker virtual machine is open. Then the telnet connection between the victim and the server machine is established. Then the command nc and the cat command is typed on the terminal of the server machine. Then the details such as the sequence number, source port number, destination port number, and source IP address and destination IP address of the target TCP connection are checked from the Wireshark on attacker machines after running the telnet command. After that, the Python program based on the details and data which is shown in the slide is written on the Python program. So the last step is the program is run by using a command using a command sudo python syn on the terminal of the attacker virtual machine. So now the new spoof TCP package is created successfully as shown in the slide. How we know whether the TCP session hijacking is success? So actually we can obtain a same result when we conduct a TCP session hijacking with a networks and the escape tools. After a successful attack, when we type something on the command prompt of the server machine, so the program will frozen. We also can base on the observation from the Wireshark. We can observe that they have many TCP retransmission to prove that the TCP session hijacking is success. So from this task 4, we can conclude that we can conduct a TCP session hijacking with the two tools, which is a networks and escape tools. So I will continue present the task 5, which is a reset reverse shell using a TCP session hijacking. First and foremost, I will explain the reverse shell. Reverse shell is a common hacking technique which is a shell process running on the removed machines and will be connected back to the attacker machines. So this allows the attacker to attack the victim machine easily and conveniently. Reverse shell is created by using a TCP session hijacking. It allows the attacker to attack the victim machine without typing any command on the victim machines. So the attack needs to run a reverse shell command only by contacting the TCP session hijacking on the attacker machine. So how we creating a reverse shell using a TCP session hijacking with escape tools? So first, the Wireshark on the attacker machine is open. Then a telnet connection between a victim virtual machine and the server machine is established by running a telnet command, which is a telnet 10.0.2.5. Then the command nc type and run on the terminal of the attacker machine. This is to set up the TCP server listening on the port 9090 and wait for the connection request from the server machine. So the details such as a sequence number, source port number, destination port number, source IP address, and the destination IP address of the target TCP connection are checked from the Wireshark on the attacker machines after running the telnet command. So the Python program based on correct details and the data, which is a bin branch data, which we can see on the slide, is written on the Python program. So the last step is the program is run by using a command sudo python task 5 on the terminal of the attacker machine. So the new spoof TCP package is created successfully. So how we know whether the reverse shell is created? After a successful attack, the nc command, which is executed on the attacker machine, will receive a connection request from the server as shown in the slide. After that, the attacker also can control all the shell program running on the server as shown in the slide also. And we can also base on the observation from the Wireshark. The server machine has replied the request to the attacker machine as shown in the slide also. So we can observe have many retransmission from the Wireshark on the attacker machine to prove that the attacking of the TCP session hijacking is conducted successfully. So from this task 5, we can conclude that the reverse shell can be created by using a TCP session hijacking. Conclusion of this mini project: TCP protocol provides an order and reliable communication channel for application, and it is used in an established TCP connection between the two machines. So the TCP protocol is not designed with any built-in security mechanism to protect the TCP protection between the two machines. So the TCP connection is attacked by the attacker easily. 5 times of the attack include the SYN floating attack, TCP reset attack on the telnet and SSH connection, TCP reset attack on the video streaming application, TCP session hijacking, and creating a reverse shell using a TCP session hijacking are discussed in this mini project. Proof that the attacker can attack the victim machine successfully. So from this mini project, we also can learn that the security need to be built in when designing a network protocol to prevent the attack from the potential attacker. So that's all from our group. Thank you.